Let's look at 2A. It asks us to explain why a linear regression model based on these data is unreliable on a day when the mean temperature is 24 degrees centigrade. Well, I've highlighted in the table the smallest and the highest value for temperature. So it goes from 13.2 up to 19.3. So in other words, 24 degrees centigrade is outside the range, so we would need extrapolation. So what we'd write would be something like 24 degrees centigrade is outside the range of data recorded. It would require extrapolation, so is unreliable. Part B asks us, what is measured by the product moment correlation coefficient? We'll refer to that as the PMCC, and that measures the linear relationship between our two variables, T and W. In question 2C, we're asked to state our hypotheses clearly at the 5% significant level, whether or not the PMCC for the population is greater than 0. Well, to start, our data from the table with the T and W values, there are 9 values, so n equals 9. And we're given at the top of the question as well, it tells us that the PMCC, which is our letter R, equals 0.609. So what we really want to do is we want to set up a hypothesis test, and we want to test whether our R value is going to be in the top 5%. If it is, then we're going to reject the null hypothesis. So we're going to say that H0 P is going to equal 0. That's our null hypothesis. And then our alternative hypothesis, H1, we're going to test for P is greater than 0 because we're at the right-hand tail of the test here. And we're going to use a 5% significance level. So what we need to do is we need to find this value from PMCC tables. And I'm going to show you how to do that now. On screen now, I've got a small bit of the PMCC table, and I've highlighted the 5% column, and I've highlighted the sample size of 9. And you'll see where those two meet, this p-value is 0.5822, and that's the value we need to put on our diagram. Now I've added the 0.5822 to the diagram, so you can see that is here. And our value of R is 0.609. Now you can see that's bigger than this value. So it is in this top tail here. So basically, R is in the critical region, so we need to reject the null hypothesis. So there is evidence that the PMCC is greater than 0. An example of what we'd write then would be, as R equals 0.609 is in the critical region, reject H0. That's the null hypothesis. So there is evidence that the PMCC is greater than 0. Finally, looking at 2D, it says that another location gave a set of data with T bar, that's the mean, is 27.2, and W bar as 3.5. So the 27 degree temperature, if you look at these above here, these are all sort of in the teens. The 27 suggests it's higher than the UK. Now if you look at the wind speed there, 3.5, looks to be lower than the one for the UK. So at the other locations we can get abroad, it's either Jacksonville, Perth or Beijing. Now Jacksonville and Perth are both near the sea, so they're probably quite windy, so it's possibly Beijing. So a suggested answer for 2D would be higher mean temperature of 27 degrees C suggests not the UK. The low wind speed rules out Jacksonville and Perth as they're close to the sea, so the answer is possibly Beijing.